Hi everyone, welcome to machine learning using Python. This is support vector machines module 8, part 2, session 15 being conducted by uh, Jaimit Prasawa, our instructor. Jaimit, go ahead, take over on the SVM part 2, which is more on the what do you call Scikit-learn, which you are going to go through the different sample sets and present them. Okay,
Sure.
take care. Thanks.
Yeah.
The floor is yours.
Yeah. Thank you. Thanks a lot. And hi, everyone. This is machine learning using Python. Support vector machines, module 8, 2, and session 15. So before starting this session, let's just have a recap of the previous session. In the previous session, we of the support vector machines, we discussed what is support vector machines, how they work on linearly separable and non-linearly separable data. In linearly separable, it was simple that the data, as the data was linearly separable, it was easier to know the plane and classify both the classes. But in non-linearly separable data, we used a kernel trick, which uh, which was basically transforming the data into high dimensional, where we were able to classify or separate the data using a hyperplane. Then we discussed about the types of SVM, linear SVMs, hard margin, soft margin, and non-linear SVMs, etc. Then theoretically comparing the SVMs execution with other classes like uh, neural nets, logistic regression, and stuff. In the end, we discussed about the applications of support vector machines in a different field like text classification for sentiment analysis and stuff. In this session, we'll be executing support vector machines using 3 different data sets. We'll start with first the iris data set. So if iris data sets are very common among the machine learning community, but just in case if you are watching this for the first time, this is how the iris data set is. It consists of 3 class labels: Setosa, Versicolor, and Virginica, as you can see in the class labels uh, uh, in the table. You can find the last column as class label, and those are the values. The table consists of the columns sepal length, width, and petal length and width. As the diagram also says which are the sepal parts and which are the petal parts, and what are the width and the length, as it says. So the iris dataset contains 50, 50, 50 samples of Setosa, Versicolor, and Virginica. And other are the features, which are the attributes, measurements, or dimensions of the flowers. So we'll be using SVM on this iris dataset, for which we'll be using NumPy, Pandas, Matplotlib for plotting purpose, and Scikit-learn for using the SVM, and also for the standardizing the values, train, test, split, and stuff. In the end, also the Seaborn library for visualizing the values in conjunction with the Matplotlib library. So first we load the dataset in iris and give the data for x and y for the target values. And when we when we make the data frame and get the info regarding the data set, you can see that it has 150 entries, 50 for each type of flowers, and on the columns that it contains, and the memory it uses, and which are the you can see that 4 takes float type values, and 1 takes integer type values, which are the species, which is our dependent variable. So uh, displaying first few records of the data set, you can see that it is giving for the species 0, which belongs to Setosa, or a species label 0 belonging to Setosa, the sepal length, width, and petal length and width. And just to confirm the value counts for the species, you can see that Setosa versicolor and virginica belonging to label 012 all has 50 records. Visualizing the data using the pair plots, you can see how they are uh, how they form the display the relation between different colors, using different colors and different dimensions. So you can see that in sepal length for in the x and y in the sepal length, and there is a diagonal matrix that is formed, which are for the distributions. As much as the graphs overlap onto each other, those are the ones that it means that the features are largely correlating to each other and or largely similar. As you can see in the petal length and the label 0, which belongs to Setosa, it's completely different. And same goes for petal width in the last. So as we are using the 0, 1, 2 as the labels, we will be just simply mapping those labels with their respective flower names or the species and creating the array state df. So now, instead of labels occurring as 0, 1, 2, it will occur for Setosa versicolor and virginica. Then we split the data sets for XY train test splits and also standardize those values. When we use the SVC, which is support vector machines for support vector classifiers, and using the kernel linear random state 40, giving it a random state of 42 and fitting the data to the model and making the predictions on ypred and saving it on ypred, and also evaluating the model for the predictions that were made. We are going to use the confusion matrix. Now, this confusion matrix is not exactly the 2 by 2 confusion matrix. Here we are creating the true labels, which are set on the y-axis, and the x-axis contains the predicted values. So you can see that how Setosa has been fully all correctly predicted, whereas versicolor one was predicted as wrongly as virginica, and virginica itself is fully predicted correctly. So if we go for the small data set and using the SVM, we have a pretty solid model. Now, this was for the iris dataset we were going to use. The next dataset that we are going to use is for customers' default payment. Now, you can see the description on the screen that the study associated with the dataset focused on customers' default payments and compared the predictive accuracy of the probability that a client will default on payment across 6 data mining methods, which can be regression, logistic regression, neural nets, and stuff. But now this is the description regarding the data set, and we are only using it for SVM. So for the binary variables, there is a column in the data set which is for default payment for yes equals to 1 and no equals to 0. And there are 23, sorry, there are 23 total explanatory variables. The additional information regarding the dataset, you can see that it starts with column X1, which is the amount of credit given. Then X2 contains gender, for one for male, two for female. Then the education from 1 to 4. 4 regarding others means 4 can the education column can have more than values greater than 4, like 5, 6, and stuff. And then a marital status, the age from X6 to X11 is the history of the past payment. Then X12 to X17, the amount of bill statement for the respective months, starting from September to April. And from X18 to X23, the amount of previous payment for starting from September to April. So we import the necessary libraries that we want, starting with pandas, numpy, and cbon. Then Scikit-learn for various uses for splitting the dataset, resampling the dataset. You will see how why different parts of the libraries are imported as we go along. So first, reading the dataset that is in Excel file, and we'll give header equals to 1 because we are not going to use the X1 to X23 as our column names. What we'll be using are these values, like ID, limit balance for gender or sex, then education, marriage, and stuff. So displaying the first 10 records of the dataset, you can see how the values look like and how the different columns have different kind of values. The information regarding the dataset, you can see that they are all integer data type. The memory used for using the dataset is 5.7 MB, and there are total 30,000 entries and 25 columns. So this is how all the columns look like, but not all the columns are useful to us. So we'll be eliminating the ID column that was there. You can see the first column is ID. So we'll be dropping this ID column as it doesn't serve any purpose to us. And there is a last column called as a default payment next. So that name will be renamed to default only. Now, we'll be checking for the invalid or the missing values that can exist in the data set. So we'll be checking for sex, marriage, education, and age. Now, education and marriage, both of these values, they contain some of the values. Like for example, in education, there are existing of values of 5 and 6. Now, according to the 0 to 4, we have till high school, but it can mean that 5 and 6 means masters and or BTech degree, or then masters and then PhD. But this is not something that is stated in the dataset, though. So we'll be uh, not using those values. The same goes for a marriage column, including 0 as an invalid value. So we'll be one hot encoding all the values that we that we want to use. So before one hot encoding, we'll be only using the values which does not contain those missing values or inappropriate values that are not in the context of the data set. So for all the values where the values of the column education and marriages are not 0, we make the data frame called df no missing data. And you can see now we have total 29,932 entries. When we check the number of values for the data set for the default which we are predicting, the default value of 0 or no is very large compared to the default value of 1 or yes. So that's why we will be downsampling the data set, and we'll be downsampling both the data set to 1000 for both the class labels as 1000 and merge it or concatenate it into the df downsample. So the total length will be 2000 for the final data set of downsampled data set. Sorry, final data frame of the downsampled data frame. Now we one hot encode the columns, and you can see that after one hot encoding, we uh, we save those values of into x encoded, and when we print the values of x encoded, these are the columns that we get. Now we split the dataset for training and testing purpose. So we create the X, Y train and test splits. And as those are the scale values, we'll be saving them into X train and test for the scale values. Then using it for support vector classifiers and making the predictions, and using the scoring of accuracy. The confusion matrix that we get for the model and its prediction is this. You can see the true positives and the false negatives value. And there are 63 wrongly predicted values. And for the false positive, it's 126 values. The layout of the confusion matrix is the same as y-axis containing the true labels and the x-axis containing the predicted labels. So, moving further. Now we find the optimal values using the grid search CV. And using the accuracy score again, and making the confusion matrix. You can see that before is the one that we just saw, which is on the left, and on the right is the after using the grid search CV. We are getting a little improvement from 339 239 to 244. So there's a bit of improvement using grid search. Now, after this, we'll be visualizing the data for so for the model that we have created, and using the min max on the x and the y values, and making a mesh grid which takes those min max values for the x and y. So because the because it's a multi-dimensional data, it is hard to plot a graph. So that is the reason that we'll be using PCA, which is a principal component analysis. So which helps us to plot the graph on the x-axis, which covers the most amount of variance, and then the second most amount of variance which is covered is plotted on the y-axis. So the green are the ones that defaulted, whereas reds are the dots that did not default. So you can see that the ones that are closer to the contour that is appearing on the background, the reds are the ones that did not default and are uh, belonging to or closer to that contour compared to the ones that is appearing above in the graph, which is for defaulted ones. So to go for the codes, these are the ones that we used for the default customer default data set that we just discussed. This is reading the data set, printing the first 10 values of the data set. You can see that here the default payment next month is the uh, uh, dependent variable that we are trying to predict. The information regarding the data set, you can see 30,000 entries and all the columns. We dropped the ID from the dataset as well as renamed the dataset to the column, and renamed the last column to default, because some of the values in marriage and education contain 5 and 6, which were not in context with the dataset that we are using. So that's why we only considered the non-zero values for marriage and education both, and having these many entries in total to work with. Counting the plots, we counting the classification types. One had so it was an imbalanced data set, so we downsampled the data set and used one hot encoded to use it for our use. Split the data set that we one hot encoded with the scaled values or normalized values, and then made this confusion matrix. After predicting, you can see the accuracy of 68.50%. and the values it provides. Optimizing the model with a grid search CV, and this is the optimized evaluation after that. Now we reduce the dimensionality using the principal component analysis because there were many dimensions to the data, the dimensions that were used that we were not be able to follow or make a graph of. So that's why we reduced it to 2 and made a scree plot. Now we made a scree plot because we wanted to know the value, as if I know the values for the bins, sizes of the bins are in the scree plot are very small, but if you count the one elbow, you can find it around here where the value is 10. So using the grid search CV and the parameter grid again for these values, and going for these values of C and gamma. C and gamma are the hyperparameters as we discussed in the previous ones, which where the value of C kind of controls the values of uh, trade-off. For the soft margin SVMs, and then the kernel here used as RBF radial basis function. Now running this grid search CV and fitting the values again with the PCA train scale. This is the graph that we get. So moving further with the last data set, third data set, which is the last for this session, is a wine quality data set. So you can, this is the description of the data set. Now data sets can be used for anything. So here we are using this data set for applying SVM. You can see that why the dataset, how from where the dataset was collected, and for what use the dataset was used, psychochemical tests. So first we'll be reading the dataset and displaying the first 5 values of the dataset. The information of the dataset, you can see that there are total 12 columns. Out of them, 11 take float type values and 1 take integer type values, which is the quality column, which is what we are will be trying to will be predicting using the describe function for describe method for the on the data set. You can see the mean standard deviation and the percentile values of 25, 50, and 75%, and at max, which are the values that it takes, as well as all the column names, fixed acidity, volatile acidity, citric acid, etc., till pH values, sulfates, and alcohol content. So, as there are many values and we want them to be considered equally, we will be standardizing those values. First, we create the X and Y values, and lastly, we will be using the scale values of both the X and Y for training the set. So after so we'll directly use the grid search CV here for the SVC for the SVC model or the support vector classification model, and CV value of 5. And make the predictions on the uh, save the predictions on the whiteboard, getting the accuracy score as well as the classification report. You can see that the accuracy score is 84.2%, and the last one is the classification report where we get the precision recall and F1 score. Now you can see the precision recall and F1 formulas on the right side of the screen on the top, and that recall is equals to true positive values divided by true positives plus false negative values. The precision is true positive divided by true positive plus false positives, and the F1 considering both the recall as well as the precision values is 2 into recall into precision divided by recall plus precision. In the end, we as the wine quality set also contains is a multi-dimensional data set, so we reduce the data set for plotting the values to 2. So for on the x-axis we have PC1, and on the y-axis we have PC2, which are the of most the components which are having the most variance and the second most variance. So when we plot the graph, you can see that reds are the ones which define the high quality wine, whereas purples are the ones that define the kind of low quality wine from the red. And you can see that red also tends to be plotted on the lower left of the graph compared to the purple ones. Of course, there are those are mixed values, but you can see the concentration of red more on the lower left of the graph, not origin but lower left. You can see because it is lying in the minus minus quadrant. So this was it for the sorry. Yeah, for the wine quality, we read the data set, displayed the first few values, which were uh, defined by displayed the first few values, the information regarding the data set, total entries we have, and the total columns. And the quality was the one that we tried to predict. Then we use a describe method in order to get the standard mean, mean, standard deviation, the percentile values. Then using the Scikit-learn's train test spread, and the standard scaler for using the standardized values of the X and Y spread that we created using the train test spread. Getting the support vector classification from the scikit-learn.svm, and that's the one that we have used for the whole session. Making a parameter grid for the C value, different C values as well as the gamma values, and the kernel as RBF. So here you can try one thing is that instead of RBF, you can give the linear and poly for the different kernel, and you can get a bit of better accuracy for the ones. I have only used RBF here for giving it as an assignment. So getting the accuracy, you can see that 84% almost, 84.2% or 84.3% is the accuracy, and you can see the precision as well as recall and F1 scores. When we visualize the data for using the PCA, as we use PCA for being multi-dimensional data set, and it was not easy to capture all of them. So we use the two most components which captures the most variance and plot it on X and Y respectively. And you can see the graph that we got. So this was it for the session on support vector machines, which is we focused totally on executing SVM on the different data sets, which was on iris data set, customers default payment data set, and wine quality. The references and the data sets that were used were this, and you can go and check around and play around with the data sets and different values for your practice purposes and understanding the concepts on the support vector machines. So yeah, this was it for the support vector machines. Thank you.